What's up, fellas? So welcome back to our OSPF series. In the last video, we went over virtual link and redistribution configuration. And in this video, we will go through area types and how we can configure them. So if you can see in the topology here, we have area 19, which we are supposed to configure it as a stub. And let's go over to our 9 real quick and see what we have there. Okay, so on our 9, let's just say show route for OSPF and kind of see the OSPF related routes. And here we have it. We can just do the TERS keyword and if you can see here, all these are the routes that R9 has learned via OSPF. And take a look at the next hop. What do you see? All the routes have a single next hop, which if you look in the topology here, it is pointing back to R1. So R9, it's kind of like a dead end. So now the question here, you should ask yourself, does R9 really needs to maintain all these routes if they are all going to the single next hop? Yeah, probably, but yeah, probably yes, probably no. So why not trick R1 into sending a default route to R9 instead? So what stub area does is it filters LSAs type 3, 4, and 5, and it's going to replace them with a type 3 default route. Let's go to show OSPF database. So here are the LSAs that have been that are in the LSDB of R9. So if I configure area 19 as a stub area, meaning here R1 will stop LSA type 4 and it will stop LSA type 5, and instead it is going to generate a type 3 default route and it will send it to R9. So the database, the LSDB will be reduced. This one will be gone and it will be replaced with a single default route. So these are the only routes that will remain with a default route. So let's go and configure that. I'm going to start off on R9. I'm going to edit. So edit protocols OSPF area 19. And here really what I'm going to do is just say set stop. This one right here. Top, commit and quit. As soon as I do that, if I say show OSPF neighbor, the adjacents will go down because there is a area type mismatch. So I have to go back to R1, so show OSPF neighbor. Here the adjacents will still be there, but until the dead time As you can see, it's reducing 5, 4, 3, 2, 1, and the adjacent will just go down like that. So here I'll go to edit and I'll say edit protocols OSPF area 19. It's show here, I have nothing. So here I'm going to say set stub, say top, commit and quit. Soon as I do that, the adjacents will come up. Now, if we flip back to R9 and I say show route, what do I see here? Yes, of course, the external routes have gone. It's just a show OSPF database. I still have them in my SDB. Let's just say clear OSPF database. Okay, now if I say show OSPF database, it is going to relearn only these are the type 1 LSA, which they are actually generated within the area, and type 3 LSAs that are being learned from other areas. They pass R1 and generate type 3 LSA and inject it into R9. But the default route is nowhere to be seen. Why? Here's one thing with Junos. If you are configuring a stub area, you also have to, let's go back to R1, edit protocols OSPF area 19. So if I say show, if you are configuring a stub area, you also have to specify the default metric for the default route, unless it is not going to generate the default route. This one is for Cisco, it will just do that by default, but for Junos you have to specify the metric. So let's set stub. If you hit question mark, you will see the default metric, and then you're going to specify, let's just say 150. Boom. Top, commit and quit. Let's flip back to R9. First say now show route. You will see now it has generated a default route with a metric of 151. Show OSPF database. If you look back in the OSPF database, you will see the default route being injected as a type 3 LSA. So, and the database has kind of been reduced. So that's it with stub area. Let's go over to R9, let's go over to area 104, and we are going to set this as a totally stub area. So a totally stub area, what normally it will do, it is the same as stub area, but here it will block type, the ABR will block type 3, type 4, and type 5 LSAs. So it will actually replace all these routes with a default route. So let's flip back to R4. R4, OSPF. This one right here. So we can go back to R10 also and say show OSPF neighbor. Say show route. I have all this bunch of routes on R9, on R10, and we need to set this as a total stub area. So what I'll do is go to edit and edit protocols OSPF area 104, and here really what you need to do is just say set stop. That's it. Stop, show pipe and compare, say commit and quit. And if I go back to R4, say edit protocols OSPF area 104, same way as you did on the stub area. It says set, you would say set stub. So here you have to include the keyword no summaries, because we are also blocking type 3 LSAs. So I'll say no summaries, and of course I'm going to specify the default metric for the default route that will be sent to area 104. So I'll say 104, or if you can call it show pipe and compare, commit and quit, show OSPF neighbor. Let's go over to R10, show OSPF neighbor, show route. So all the routes that I previously have, if you look here, all these, all the OSPF routes have gone. I only have the routes that are within the area and the default route that has been generated by R4. So show OSPF database. I didn't clear the OSPF database, so let's say clear. Not sure. Take some time to. Yeah, well, there we go. So we have type 2 LSA that is being generated by the DR, and the DR of this segment is 10, I think. Yeah. Show OSPF neighbor detail. Of course, 10 is the DR, so it's the one advertising this subnet in between here. Okay, so that's how we configure totally stubby area. Let's go to the not so stubby area, this one over here. So the thing with not so stubby area is, let's just say you have your OSPF domain and you inherit a network somewhere that's running a different routing protocol. If if for example I want to prevent LSA type 5 from entering this area from other areas, maybe this was originally a stub area and I have prevented LSA type 5, and all of a sudden I have to inherit another network that is running a different routing protocol. So what do I do here? Because if I redistribute the RIP routes into the into the stub area, they will not be redistributed because stub area by default prevents LSA type 5. So the alternative was to create another type of area called not so stubby area. So here what is going to happen is, if I set this as a not so stubby area, it will accept the external routes, but they will be redistributed as type 7 area, type 7 LSAs. And then when they are being sent to the rest of the OSPF domain, the ABR here, R2, will convert the type 7 LSAs into type 5 LSAs. And at the same time, it is going to prevent type 5 LSAs from other areas to enter into the NSSA. So let's see how we configure that. Let's start off from R5. Edit OSPF Area 25, I believe. Yep. Show. Set NSSA. Oh. Commit and quit. So that's it. Show OSPF neighbor. The adjacent should go down. And at this juncture, I shouldn't have. So the routes are still on the routing table until R2 stops responding. Show OSPF neighbor. Yeah. So edit OSPF Area 25. So here I'm going to set NSSA. And then you need to specify the default metric. The default LSA. So here I'm going to redistribute. To send the default route into the NSSA as type 7, and I need to specify the default metric, let's say of 10. Let's go back to the top, show and compare, commit and quit, show OSPF neighbor. Let's go back to R5, show OSPF neighbor, show OSPF database. Okay, so what do we see here? As you can see, it's clear. OSPF database, show OSPF database. Okay, now this is a not so stubby area, and if you can see, all the RIP routes have been redistributed into the area as NSSA. This is type 7 LSA, and I also I also send a default route from ABR into the area as type 7, and these are the summary routes from other areas, and of course this is the type 2 that was generated by the DR of the segment, and type 1 LSAs that are generated on that area. So that is how you configure a not so stubby area. To configure a totally stubby area, all you need to do is to say you are going to you are not going to send the summaries here. So let's do that. R2, say edit. I can say set protocols OSPF area 25 stub NSSA, no summaries. So all it's going to do is going to add the no summaries keyword, say comment and quit. Let's go back to R5 and say show route do I have here? Show OSPF database. You see my database has been reduced. Show route. All I have here is yeah, OSPF database. Show route. This is R5. Show OSPF database. Clear OSPF. Maybe. OSPF. Do I still have routes from other areas? Hang on. Okay, I think I was not just being patient enough and show out for the OSPF. As you can see, all the OSPF routes have gone and I didn't do anything. So say show OSPF database, and if you go back to R8 now and say show route protocol RIP, all you see is your default route. This has been generated, redistributed all the way from OSPF, passes through from R2 all the way down here. So can R8 actually reach R9? Ping 10.9.9.9. Rapid. Yeah, can reach it. So I think we are done here. On these areas, actually, I think there is nothing we can do here because the best design is you have to find a way to attach your area 67 into the backbone. But other than that, really, I'm not sure if you can have an area of a virtual link to be a stub. I think that is not allowed. And that being said, we should be done with our OSPF. And until then, I'm signing off and I will see you in the next video.